According to NFPA 70, specifically National Electrical Code Section 700.9b, emergency lighting fixtures must be wired on separate circuits from those supplying normal lighting or other loads. This means the 120-volt circuit feeding emergency lighting units cannot be tapped off a general lighting circuit. The reasons for this requirement are threefold. Firstly, to ensure that emergency lighting will remain operational in the event of a failure or interruption of the general lighting circuit. Secondly, to prevent overloading of the general lighting circuit, which could cause it to trip and cut power to both the emergency and general lighting. Thirdly, to facilitate the testing and maintenance of the emergency lighting system without affecting the general lighting. There are exceptions to this rule, such as when emergency lighting fixtures are powered by a battery-powered inverter as detailed in Section 700.12c. There is another exception when emergency lighting fixtures are wired on Class 2 circuits, found in Section 700.13. Finally, emergency lighting fixtures wired on fire alarm circuits, as per Section 760.121, are another exception to the dedicated circuit rule. Let's delve deeper into each aspect. Firstly, the requirement for dedicated circuits ensures the reliability of emergency lighting during power outages. Imagine a scenario where the general lighting circuit fails due to a fault, overload, or scheduled maintenance. If the emergency lights were tapped from the same circuit, they would also go dark, defeating the purpose of having emergency lighting in the first place. By having a separate, dedicated circuit, the emergency lights can continue to function, providing illumination for safe egress and essential operations. Secondly, preventing overloading of the general lighting circuit is another critical reason for this requirement. General lighting circuits are designed to handle a specific load. Adding emergency lighting to this circuit could potentially overload it, especially during peak demand. This overload could cause the circuit breaker to trip, plunging the area into darkness, including both the general and emergency lighting. A dedicated circuit for emergency lighting ensures that the general lighting circuit operates within its designed capacity, reducing the risk of overloading and maintaining the integrity of both systems. Thirdly, the dedicated circuit facilitates easy testing and maintenance of the emergency lighting system. Routine testing and maintenance are essential to ensure that emergency lights are functioning correctly. If the emergency lights are on the same circuit as the general lighting, any testing or maintenance work could disrupt the general lighting, causing inconvenience and potentially affecting productivity. A dedicated circuit allows for testing and maintenance of the emergency lighting system without affecting the general lighting, minimizing disruptions and ensuring that both systems are properly maintained. Now let's examine the exceptions to the dedicated circuit rule. The first exception is when emergency lighting fixtures are powered by a battery-powered inverter, as described in Section 700.12c. In this configuration, the emergency lights are not directly connected to the general lighting circuit. Instead, they are powered by a battery that is kept charged by a separate circuit. During a power outage, the inverter automatically switches to battery power, providing uninterrupted illumination. Because the emergency lights are not directly dependent on the general lighting circuit, a dedicated circuit is not required. The second exception is when emergency lighting fixtures are wired on Class 2 circuits, as outlined in Section 700.13. Class 2 circuits are low-energy circuits that are considered safe to touch. These circuits typically operate at low voltage and current levels, reducing the risk of electrical shock. When emergency lights are powered by Class 2 circuits, the risk of overloading the general lighting circuit is minimal, and a dedicated circuit is not necessary. The third exception is when emergency lighting fixtures are wired on fire alarm circuits, as specified in Section 760.121. Fire alarm circuits are designed to be highly reliable and are typically powered by a separate, dedicated power source. These circuits are also monitored for faults and are often equipped with backup power. When emergency lights are connected to fire alarm circuits, they benefit from the reliability and redundancy of the fire alarm system, and a separate dedicated circuit is not required. In summary, National Electrical Code Section 700.9b mandates that emergency lighting fixtures be wired on separate circuits from those supplying normal lighting or other loads. This requirement ensures the reliability of emergency lighting during power outages, prevents overloading of general lighting circuits, and facilitates easier testing and maintenance. However, there are exceptions to this rule, including when emergency lights are powered by battery-powered inverters, Class 2 circuits, or fire alarm circuits. Understanding these requirements and exceptions is crucial for ensuring that the emergency lighting systems comply with code and provide adequate illumination during emergencies. Now let's consider some practical scenarios. Imagine a commercial building with numerous offices and hallways. The general lighting in these areas is powered by several branch circuits. To comply with Section 700.9b, the emergency lighting units in these areas must be connected to a separate, dedicated circuit. This circuit should be clearly labeled as an emergency lighting circuit and should not be used to power any other loads. In the event of a power outage, the emergency lights will automatically illuminate, providing safe egress for occupants. Alternatively, consider a small retail store with a limited number of emergency lighting units. In this case, the store owner might choose to use battery-powered inverters to power the emergency lights. This would eliminate the need for a dedicated circuit and simplify the installation process. However, the store owner would still need to ensure that the inverters are properly maintained and that the batteries are regularly tested to ensure their reliability. Another scenario involves a healthcare facility with a complex emergency lighting system. In this case, the emergency lights might be connected to the fire alarm circuit, taking advantage of the fire alarm system's reliability and backup power. This approach would also simplify the wiring and reduce the number of circuits required. However, the healthcare facility would need to ensure that the fire alarm system is properly maintained and that the emergency lights are compatible with the fire alarm system. When installing emergency lighting, it is essential to consult with a qualified electrician and to follow all applicable codes and regulations. The electrician can help determine the best wiring configuration for your specific application and ensure that the emergency lighting system is properly installed and maintained. In addition to the dedicated circuit requirement, there are other code requirements that apply to emergency lighting systems. These requirements cover aspects such as the type of lighting fixtures, the amount of illumination required, the location of emergency lights, and the testing and maintenance procedures. It is important to be familiar with these requirements to ensure that your emergency lighting system meets all applicable standards. For example, the National Electrical Code specifies the minimum amount of illumination required for emergency lighting. This requirement varies depending on the type of occupancy and the area being illuminated. The code also specifies the location of emergency lights, ensuring that they are strategically placed to provide adequate illumination for safe egress. Furthermore, the code requires regular testing and maintenance of emergency lighting systems to ensure that they are functioning correctly. These tests should be documented and records should be kept for inspection purposes. By following these code requirements, you can ensure that your emergency lighting system is reliable and effective in providing illumination during emergencies. It is also important to consider the type of emergency lighting fixtures used in your installation. There are various types of emergency lighting fixtures available, each with its own advantages and disadvantages. Some common types of emergency lighting fixtures include battery-powered units, generator-powered units, and central battery systems. Battery-powered units are self-contained and provide illumination during power outages by using a rechargeable battery. These units are relatively easy to install and maintain, but they have a limited runtime and may not be suitable for large areas. Generator-powered units are connected to a generator that provides backup power during power outages. These units can provide longer runtimes than battery-powered units, but they require more complex installation and maintenance. Central battery systems consist of a central battery bank that provides power to multiple emergency lighting fixtures. These systems are typically used in large facilities and offer high reliability and long runtimes. When choosing emergency lighting fixtures, it is important to consider factors such as the size of the area being illuminated, the required runtime, the maintenance requirements, and the cost. It is also important to choose fixtures that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. This ensures that the fixtures meet safety standards and performance requirements. In addition to the type of lighting fixtures, it is also important to consider the type of lamps used in the fixtures. There are various types of lamps available, including incandescent lamps, fluorescent lamps, and light-emitting diode lamps. Light-emitting diode lamps are becoming increasingly popular for emergency lighting applications due to the energy efficiency, long lifespan, and instant-on capabilities. Light-emitting diode lamps consume less energy than incandescent and fluorescent lamps, reducing operating costs and extending battery runtime. They also have a much longer lifespan, reducing maintenance requirements and replacement costs. Furthermore, light-emitting diode lamps turn on instantly, providing immediate illumination during power outages. When choosing lamps for emergency lighting fixtures, it is important to consider factors such as the light output, the color temperature, the energy efficiency, and the lifespan. It is also important to choose lamps that are compatible with emergency lighting fixtures and that meet all applicable code requirements. In conclusion, installing self-contained battery backup emergency lighting units requires careful consideration of the National Electrical Code, particularly Section 700.9b. Adhering to the dedicated circuit requirement, understanding the exceptions, and selecting appropriate lighting fixtures and lamps are all crucial for ensuring a safe and reliable emergency lighting system. Consulting with a qualified electrician and following all applicable codes and regulations will help you achieve code compliance and provide adequate illumination during emergencies.